Now that we know how to find a regression line, we want to answer some interesting questions. It appears that the formula can be applied to any dataset, and it is true. Here are the examples of the regression lines superimposed on various datasets. As you can see, all three datasets have the same linear regression. However, there are some clear distinctions between the datasets. Here's another example of such behavior. This means that some datasets have stronger, more obvious linear relations than others. To determine how strong the linear relation is between the two variables, we introduce the coefficient of determination r squared. To compute the coefficient of determination r squared, we have the following formula. For example, let's find the coefficient of determination of the line of best fit for the following dataset. To do this, we are going to use the following template. First, we need to find the average input and output. X bar is 2 and Y bar is 3. We subtract X bar from each value of X to fill out the third column, and then square each entry to get the fourth column. We subtract Y bar from each value of Y to fill out the fifth column, and then square each entry to get the sixth column. We multiply each entry from the third column by the corresponding entry from the fifth column to get the seventh column. We add the values in the fourth column to get S double X. We add the values in the sixth column to get S double Y. We add the values in the seventh column to get S XY. Finally, we set up a formula and compute the coefficient of determination, which is equal to 0.25. The coefficient of determination is a measure of how strong is the linear relation between the two variables. R squared equals 1 corresponds to a perfect linear relation, and R equals 0 corresponds to the absence of any linear relations. In our example, R squared is equal to 0.25, which is an indicator that linear relation between the two variables for which the data was presented is not strong. Can you guess which scatterplots below have the highest R squared? How about the lowest? The charts on the left demonstrate a perfect linear relation, so the coefficient of determination there is equal to 1. The charts in the center and on the right demonstrate a less than perfect linear relation, so the coefficient of determination there is much less than 1. While each vertical pair of scatterplots demonstrates the same coefficient of determination, there is a clear difference between them. To quantify this difference, we use the linear correlation coefficient R. To compute it, we again have to do a bit of math. To compute the linear correlation coefficient, we have the following formula. For example, let's find the linear correlation coefficient of the line of best fit for the following dataset. To do this, we are going to use the following template. We fill out the table the same way we did for the coefficient of determination. We compute the standard deviation of the input variable by adding the values in the fourth column and dividing by n-1, and then taking the square root. We compute the standard deviation of the output variable by adding the values in the sixth column, dividing them by n-1, and then taking the square root. Finally, we set up the formula and compute the linear correlation coefficient, which is equal to 0.5. The linear correlation coefficient is another measure of how strong is the linear relation between the two variables. R equals +1 corresponds to a perfect positive linear relation, and R equals -1 corresponds to a perfect negative linear relation. And the reason why it is denoted by R is because of the relation between the linear correlation coefficient and the coefficient of determination. The coefficient of determination R squared is indeed R squared. In our example above, R equals 0.5, which is an indicator that we have a positive linear relation between the variables for which the data was presented. We finished the development of the procedure that allows us to find and interpret the linear regression line along with the coefficient of determination and the linear correlation coefficient.